Alright, today we're going to begin working on section 1.5, and it's on solving inequalities, and I'm trying some new technology here, so let me get it focused. Alright, the section begins on page 119, and before we actually start solving inequalities, we need to be reminded about interval notation. There is a chart in your book on page 120 at the bottom of the page that I would encourage you to use. It would be helpful to see the different ways for writing interval notation. There are three primary ways that we will use it. One will be if we need to talk about the numbers from this point all the way to the right. Let's just say that number was 10. And this time, let's assume that that end point is included. That you show that with a bracket. So it goes all the way to the right, so that's considered to infinity, which is a sideways 8. When you write interval notation, you go from left to right. So that would be from 10 to infinity. And infinity goes on forever. It doesn't have a beginning or ending point, so you use a parenthesis. A bracket means there's an absolute starting or stopping point. A parenthesis means it's up to but not including, or indefinite ending. So that's one possibility, from a number all the way to the right. A second possibility would be from a number all the way to the left. Well, let's just say this time the number's not included. We want to just do everything up to that point. Then we use a parenthesis there. And since it's everything to the left, we call that negative infinity. Now remember, it's left to right. So we would start with negative infinity, and let's just say this point was 5 to 5. The 5's not included, so I use a parenthesis, and I'm going to always use a parenthesis when I have infinity. A third possibility would be when you want to talk about the area between two numbers. Let's say you want to go from negative 6 to positive 8. And let's say the negative 6 is included and the positive 8 is not. And we want to talk about all the numbers between there. Remembering that we go left to right, you would write the negative 6, then the 8. Because the negative 6 is included, you'd use a bracket. And because the 8 is not included, you would use a parenthesis. So these are outlined in that chart on page 120, and I think that would help you. I would also encourage you to look at the examples that are on pages 123 all the way to page 126. I think studying those examples will help you. The main thing you need to know is that when you're solving inequalities, the one thing that's different from solving equations is when you multiply or divide by a negative number. So we'll see that when we start working some problems. Alright, so let's go to the exercises, and they start on page 127, and we're going to start with number 13, and the directions are to write it in interval and as an inequality. And I see in number 13 that it includes everything from 0 to 2. So in interval, I would go 0 to 2, and both of them have brackets as being included, so that's my interval notation. Now, to write it as an inequality, which is what the second part is, when you want to write between two numbers, think of x as being between. It's between, with two less than signs, 0 and 2. The 0 is included, so I put it less than or equal to, and the 2 is also included with the bracket, so I put a less than or equal to. Alright, so there's the interval and there's inequality, and then the number line is what the problem was. Those are the 3 ways for writing it. So number 15, I see that it starts at 2 and goes all the way to the right. So that's from 2 to infinity. The 2 is included with the bracket, and we always use parenthesis with infinity. So this is from 2 till forever. So that means x is greater than or equal to 2. Alright, so the next one we're going to look at is number 25. And this time they give us the inequality, and they want us to write it in interval and as a graph. I encourage you to do a graph first. I think you'll find it easier to go from the graph then to the interval. So we're going from 0 to 4. Notice that x is between 0 and 4, so we're going to be shading between those numbers. It's got an equal to on both parts. That means we're going to have a bracket on both parts. So for interval, it's bracket 0, 4, bracket, left to right. Alright, next one is number 27. It has 4 is less than or equal to x is less than 6. Again, I would do the number line first, and it's from 4 to 6. It's in between 4 and 6, so I'm going to shade in between it. Notice the equal to is with the 4, so that'll be a bracket. There is no equal to with the 6, so that will be a parenthesis. So in interval, it's going to go from 4 to 6, doing left to right, a bracket on the 4, and a parenthesis on the 6. So we're going to use a bracket when it's either greater than or equal to, or less than or equal to. We're going to use a parenthesis when it's just greater than, just less than, or when it's got an infinity involved in it. Alright, next we're going to number 29. And it gives us x is greater than or equal to -3. So on a number line, that means we're starting at -3. Greater than is to the right. And it's got an equal to, so that's going to be a bracket. And this is going to be infinity out here. So we're going to go from -3 to infinity, and that always has a parenthesis. Alright, we're going to skip down to number 33, where this time they give us the interval, and we're supposed to draw the number line and the inequality symbols. So on a number line, this means from 2 to 5, and both are included. Since it's between two numbers, I will write x between with 2 less than signs, left to right, 2 to 5. It had a bracket on both. That means both are included, so I need a less than or equal to in both places. Alright, next let's go to number 37. It has an interval notation that looks like this. That means we're going to start at 4 and go toward infinity, so that's to the right. It does have a bracket on the 4. So that's going to be 4 to infinity with a parenthesis. And then number 39 has negative infinity, -3. So that means we're starting at negative infinity and we're going to stop at -3. So it looks like this. It has a parenthesis on the -3, so that means the -3 is not included. So those are the numbers that are less than negative 3. So x is less than negative 3 because it's to the left. That's less than. It was a parenthesis, so it doesn't have the equal to with it. Alright, so that's some practice on interval notation. Now we're going to move on to actually solving the inequalities. And we'll turn the page and go to number 59 that has x plus 1 is less than 5. And it tells us to solve it and to write it in set notation or interval and to graph it. So we're going to subtract 1 and just like we do with solving equations. So we're talking about x is less than 4. So we're going to graph from to the left of 4. It doesn't have an equal to, so we'll use a parenthesis. And with interval notation, it goes from negative infinity to 4. And the 4 has a parenthesis. Okay, we'll move on to number 61. Just like in equations, we're going to undo addition and subtraction first. So I'm going to subtract the 3 first. That zeroes out. Now I need to divide by negative 5. And this is the one part that's different than equations. When you multiply or divide by a negative number, you switch the direction of the inequality sign. So instead of less than or equal to, it's going to be greater than or equal to. You reverse the direction, and negative 10 divided by negative 5 is a positive 2. So I'm talking about greater than or equal to 2, so that's from 2 to the right with a bracket because it had the equal to. So in interval, it's going to be bracket 2 to infinity, and infinity always has a parenthesis. Alright, let's move on down to number 67. So first we need to distribute the negative 2. Then we're going to undo addition and subtraction, so we need to add the 6. Adding and subtracting something never causes you to reverse the sign. Only if you're multiplying or dividing. And this time I'm going to divide by negative 2, and because what I'm dividing by is negative, instead of less than, it's going to become greater than. And 14 divided by a negative 2, I don't know how that sign got way up there. That's supposed to be a negative 2. I'm trying to look at where I am and write at the same time. So 14 divided by negative 2 should be a negative 7. And it's greater than negative 7. So that means to the right. It doesn't have an equal to, so that'll be a parenthesis. So it's going to be parenthesis negative 7 infinity parenthesis. Alright, let's go on down then to number 71. So we're going to distribute the 1/2. Now, you can do this just like we did with equations. If you'd like to, you can remove fractions by multiplying everything by the common denominator. You don't have to do it that way, but for some of you, that will make it easier. So 2 times 1/2 times x is 1x, because 2 times 1/2 is 1. 2 times negative 2. 2 times x. And 2 times 8. Now, let's just assume, for example, just for reference on this problem, that you decide to put the x's on the left side by subtracting this x. That's a possibility. Nothing wrong with that. Now you would want to undo this 16, so you would subtract the 16, and you get that. Before you do anything else with it, I would encourage you to rewrite it with the x on the left. So think of it as taking this and literally flipping it over. So the x goes here, the negative 20 goes here, and since it was pointing to the x, it needs to point to the x. So that makes it become x is less than negative 20. So on a number line, we're going to mark negative 20. Less than is shade to the left. It has a parenthesis because it doesn't have an equal to with it. So this is negative infinity to negative 20. Remember, it's always left to right, and it's got to go in that order. So negative infinity to negative 20, and the 20 has a parenthesis. All right. Let's move on then to number 75. And this one's different in that it's 3 parts. So you do the same thing, except you have to focus on getting the x by itself in here. And whatever you do to do that, you have to do it in 3 places. So I'm going to add 7 to get rid of this. So I add 7 in all 3 places. Then I need to divide by 3, and you do that in 3 places. So I'm talking about the numbers that are between 7/3 and 4. Well, 7/3, that's 2 and 1/3. If I want to think of that as a mixed number, you can do it either way. And 4, and I'm talking about the numbers that are between it because x is between those. It doesn't have an equal to on either one, so I'll use parentheses in both places. So in interval, it's going to be parentheses 7/3, 4 parentheses. All right, next we're going to number 79. And we've got this fraction thing going on again. So I can multiply everything by 4 to clear out the fraction. 4 times negative 3. When I multiply 4 times this fraction, the 4's are going to cancel out, and I just get 2x minus 1. And then 4 times 0 is still 0. So now it's very similar to the one I just had. I just add 1 in all 3 places. And then I'm going to divide by 2 in all 3 places. So x is between negative 11/2 and 1/2. So I can write that as a negative 11/2, or if I prefer, I can write it as negative 5 1/2, whichever way. And then to 1/2, and x is between those, so I'm going to shade between them. and there are no equal to, so that'll be parentheses on both. So it's going to be negative 11 halves, 1 half, parenthesis. Alright, I want to back up and do number 77. I skipped that one and I didn't mean to. So let's go back to number 77. So I'm focusing on getting the x by itself, which means I've got to get rid of this 4. So I need to subtract 4. Now I need to divide by negative 3. And because I'm dividing by a negative number, both of these signs are going to be flipped. So instead of less than or equal to, they're going to become greater than or equal to. This will divide out and just give me an x. Negative 2 divided by negative 3 is a positive 2/3. And negative 9 divided by negative 3 is going to be a positive 3. Now, although this is correct, there's nothing wrong with it, it makes more sense and it parallels what we've been doing before if we flip this whole thing. So like I said before, think of it as just taking it and completely flipping it over. So the 2/3 goes here, the 3 goes down here, and instead of greater than or equal to, they're going to be less than or equal to. It's like you literally flipped it over. Because that puts the smaller number on the left-hand side, which makes it easier for us to think about what our number line graph should look like. So we're going from 2/3 to 3, shading in between. Both of them have equals, so we'll do a parenthesis on both parts. I'm sorry, that's wrong. We'll do a bracket on both parts. So we've got bracket, 2/3, 3, bracket. And that was number 77. Okay, I want to skip down now to number 83. Whoops, I keep forgetting y'all can't see the whole sheet. There we go. Number 83 is x plus 2 times x minus 3 and x minus 1 times x plus 1. Now, initially, this looks pretty complicated, but it's not going to be, because what we're going to do is to multiply these together. So, using the distributive property, x times x, x times negative 3, 2 times x, and 2 times negative 3. On the right-hand side, I have x times x, x times, I'm sorry, that's x squared, x times 1, negative 1 times x, and negative 1 times negative 1. Now, just like with equations, before I do anything else, I want to clean up each side. So I can combine these two to just get minus x. And over here, these two cancel out completely, and I just get the minus 1. Now, some of you would remember that when you multiply the sum and difference, you get the difference of squares. So some of you could have gone straight from this to this, and that would be fine. Well, it looks like we've got an x squared in here, which makes it a whole different ball game. But in this particular problem, if you subtract x squares from both sides, the x squares disappear, and so it is still just a first degree equation, first degree inequality. So we're going to add 6. And you can't leave a negative sign with the variable, so we've got to multiply both sides by negative 1. Multiplying by a negative reverses the sign, and negative 1 times 5 is negative 5. So I've got x is less than negative 5, so that means from negative 5 to the left, and it doesn't have the equal to, so it'll be a parenthesis. So left to right, negative infinity to 5, negative 5 rather, and it has the parenthesis with it. Alright, there's one more I want us to look at in this group, and that's number 87. We've got 3-part and we've got fractions going on. So I look at the denominators, 4, 3, 2, and I ask myself, what's the smallest number that all 3 of those numbers will divide into evenly? And that is 12. So that's my least common denominator, and that's what I want to multiply by. So I multiply 12 times 1/2. When I multiply 12 times this fraction, the 3 will divide into the 12 4 times, so I get 4 times the quantity x plus 1. When I multiply 12 times 3/4, I get 9. Now I need to distribute that 4, and then it looks like a problem that I've done before. So I subtract the 4, then I'm going to divide by the 4, this 4. I'm dividing by a positive number, so it doesn't influence the signs at all. 2/4 is 1/2. Those 4s divide out, and 5/4 I just leave as 5/4. So on my number line, it's going to go from 1/2 to 5/4. Shading in between because x is between those two numbers. The 1/2 has an equal sign, so that'll be a bracket. The 4 does not, so that'll be a parenthesis. So in interval, it's going to go 1/2 to 5/4 like that. Alright, at this point then, you should be ready to do the homework on section 1.5 from my math lab.